Okay, let's talk about what are called polynomial inequalities. The main thing here is we're going to be dealing with polynomials, which we've done already, but this time instead of polynomial equations or functions, we're going to be looking at what are called inequalities. So remember, inequality has like a greater than or equal sign, or less than or equal to sign, and we have a set of steps in order to solve these. The first thing that we want to do is isolate. That means we want to move everything to one side of the inequality and get 0 on the other side. So you'll move everything over and you'll have like greater than or equal to 0, or less than or equal to 0, or greater than 0, or less than 0. One of these four cases. Once you've got all that junk moved to one side, what we're going to do is replace, and I misspelled that there, replace the inequality with an equal sign and solve the now equation. Once we've solved the equation, we use the solutions from step 2 to write them on a number line and then find test values. We'll plug those test values into the original inequality, and then we'll use that to determine our solutions, or the interval solutions for the problem. Okay, let's take a look at an example. We're going to start off pretty basic. The first problem I'm going to give you, I'll say problem A. We're going to be asked to solve this linear or polynomial inequality 3x minus 4 greater than or equal to 2 minus 5x. Okay, so what we want to do first is realize it's a polynomial. That means that we have x's and the powers of the x's are positive integers. So like we have a 1 here and a 1 here. So let's move everything to one side. Okay, so what we'll do is we'll subtract 2 from both sides. We'll add 5x to both sides. Over on the right side, everything cancels. We'll have a 0. On the left side, we have 8x. Let's see, we'll have minus 6. Now this, you'll notice, is a linear inequality, meaning that the power on x is 1. Whenever we have linear inequalities, we can kind of skip all of the steps for the general polynomial, and that's the only case we can when the power here is 1. And all we'll do is just move things around. So I'm just going to isolate my x by adding 6 both sides. That'll give me 8x greater than or equal to 6, and we've seen problems like this already. Now what we'll do is we'll divide both sides by 8. Since 8 is a positive number, we do not have to flip the sign over. We get 6 over 8. So we get x must be greater than or equal to, we'll reduce the fraction here, 3/4. So on a number line, if this is 3/4, we must be bigger than or equal to 3/4. So bigger means this way, and we can be equal, so include the point. So our answer will be in interval notation 3/4 to infinity, positive infinity, and that would be the solution. Now let's take a look at solving a different polynomial inequality. This time it will not be linear, and we'll see when it's not linear, things get kind of ugly. I'll start out with a very basic inequality here. How about x squared is greater than or equal to 4? Okay, now this is a polynomial inequality. We'll move everything to one side, so I subtract 4 from both sides. Now notice that it is not linear. That means the power on x is greater than 1. Therefore, we have to go through all of the steps. So this was step 1, isolating. Step 2, we replace the inequality sign with an equal sign. Now we solve this equation. Now you have two choices here. You can factor this as a difference of 2 squares, or you can move the 4 over and take the square root on both sides. I'm going to factor the left. X plus 2x minus 2 equals 0. I get two solutions here. I set this factor equal to 0. I get x equals negative 2. The other solution, I set this factor equal to 0. I get x equals positive 2. So now I have found two solutions to this equation. Now step 3, I'm going to draw a number line. I'm going to put my two solutions there, negative 2 and 2. And now what I do is I break up the number line into now 3 regions. It's the region to the left of negative 2, between negative 2 and 2, and to the right of 2. Now what we need to do are pick test points. So I have to pick something here, here, and here. And this is something you always have to do when you're dealing with an inequality where the power is greater than 1. You have to go through these steps. A good test point here is negative 3. A good test point between a negative and a positive number is always going to be 0. and then I can pick something over here like 3 or 4, anything I want. Now what I need to do is step 4. I need to plug these in. I need to determine the intervals where this is true. So I'm going to plug -3 into my original inequality. Now remember, my original inequality was x squared minus 4 greater than or equal to 0. Now let's plug in -3. -3 squared minus 4 greater than or equal to 0. Now the question is this true or is this false? Well, -3 squared is 9. 9 minus 4 is what? 5, right? 5 is greater than or equal to 0, so this is true. So that means if I plug in -3, it's going to be okay. And because of the way that this works, anything to the left of -2 will work. So I'm going to put a check mark over here to signify that anything over here works. Now you plug 0 in and you test it. So I'm going to erase this. Plug in 0, 0 squared minus 4 greater than or equal to 0. Okay, now 0 squared is still 0, so I just have -4 greater than or equal to 0. Well, this is not true. A negative number is not bigger than 0. So what that tells me, that anything between -2 and 2 will not work. Then I have to plug in 3. Test the next region. So 3 squared minus 4 greater than or equal to 0. 3 squared is 9 minus 4 greater than or equal to 0. And of course that's 5 greater than or equal to 0, and that's true. So that means this region does work. Okay, so now we're ready to try and determine these intervals that are going to be our answers. So we know everything over here works. The question is, do we include -2 or do we not include -2? Well, in the original inequality, remember we had this greater than or equal to 0. And we saw earlier that when we did x squared minus 4 equals 0, that the two solutions were -2 and 2. So that means that if we plug those numbers in, we will get equality, which is allowed here. So that means we do include the point. I'll put a solid dot. Same with 2, we can include 2, and everything to the right of 2. So that little half equal sign underneath here tells us we do want to include those points. Now I'm ready for my final answer, which is going to be an interval notation. It's everything to the left of -2, that's negative infinity, all the way up to -2, include -2, so that's a bracket, unioned with another bracket from 2 on to infinity, that's from here over. And in the next video, I'll do a couple of more polynomial inequalities, and you'll see we'll follow these steps. It gets a little tedious, it's a long process, but if you follow the steps, you should be okay.